Hi, today I will be discussing a crucial topic in C programming, memory management. We will cover four key functions, malloc, calloc, realloc and free, and understand their roles and importance in managing dynamic memory. Memory management in C is all about dynamic allocation, which allow us to allocate memory during runtime. This is different from static allocation, which happens at compile time. Dynamic allocation gives our programs flexibility to handle varying amounts of data efficiently. In the practical part, we will use these steps. Malloc stands for memory allocation. This function allocates a specified number of bytes and returns a pointer to the first byte of the allocated memory. If allocation fails, it returns null. Note that the memory allocated by malloc is uninitialized, meaning it can contain garbage values. Calloc stands for contiguous allocation. It allocates memory for an array of elements, initializes all bytes to 0, and returns a pointer to the first byte. This is different from malloc, which leaves the allocated memory uninitialized. Realloc is used to resize previously allocated memory. It can increase or decrease the size of memory block, and it might move the memory block to a new location if necessary. If realloc fails, it returns null, and we must handle this to avoid losing the original memory block. Free is used to deallocate memory that was previously allocated by malloc, calloc, or realloc. It helps in preventing memory leaks by releasing memory that is no longer needed. A good practice is to set the pointer to null after freeing it to avoid dangling pointers. Okay, let's start in practice. We need to include some libs like stdio and include stdlib. Second, we print some comments like size of array. We need also allocate memory, check allocation, add some data, print data, and the last one we need free memory. Let's define the size of array like 10 unsigned, like 10. First we used a malloc function. For calloc it's the same code, but we change some parameters. Okay. And array malloc size of int multiply n, check if null, memory allocation failed. And return 1. Add data, for example, like iteration. Okay. Print data is the same code. And the last one, we need free memory. Let's run. and it works. But the good practice is to set the freeing memory variable like array to null. It's not necessary, but it's a good practice. Also, we can check memory leaks using valgrind tool. Okay, and we have 0 errors, no leaks are possible. The output. For malloc, as I said before, we change argument function from like that and change this, and that's all. The difference between calloc and malloc in practice. What if we need to add some data to allocated memory? We need to use realloc function to reallocate memory increase. And first print some comments like increase array size, allocate memory, or reallocate memory is better. Check allocation or reallocation, add extra data and print data. Increase array size, for example, like 5 extra data is pointer to int temp array realloc. First we need to give to allocated memory array and print size of int multiply by n. We need to check reallocation like tmpr is null, then memory reallocation failed. Also, we need to free array because if reallocation fails, the array pointer is exist and we need to free them, and array is equal to null and return 1. Then we can change the pointer from array to tmp array. We need to add some extra data. This is the same code. N like n minus 5 to n, print data, and Let's start. Oh, we need to put char here. And as you can see, we increase the data to extra 5 elements. Let's check memory using Valgrind tools. As you can see, we have 0 errors, no leaks are possible, free allocation, free freeze, and that's all. An important thing, it is not necessary to free temporary array, because array and temporary array points to the same memory, and if we free array, we also free TMP array. This is extra part of material, and I show you 5 extra functions to memory manipulation. First function is memset. Memset fills the first, in this example, 20 elements to 0 in memory. In this example is buffer, and we print it. Let's run. As you can see, we have two outputs. First is the output before memset, and the last one is after memset. As you can see, the first output, we have a garbage data, and the second, we just fill all elements in this buffer to 0. Second, we have a memcopy function. In this example, we copy hello string to the buffer, and memcopy just copies n bytes from source memory to destination memory. And if we run, we see two outputs. First output is before memcopy. This is a garbage data. The second one is the final copy after memcopy. We see. And the last one is memCompare function. MemCompare function compares first n bytes, in this example 4 bytes of two memory areas. In this example is data 2 and data. And if compare return 0, the areas are equal. Let's run. As you can see, memory areas are equal, but we just only check 4 elements like this. Yeah, and if we change the last one to random letter and run, memory areas are equal, because we only check for 4 elements. If we change to 5, the memory areas are not equal. Thanks for watching this video.